Right, welcome back to another video lesson. Today we're going to be carrying on with our maths series, looking at UVs and how we can do some stuff with that. But to start with, I just want to answer a quick question. So I had a question in the comments section. Question was, is there a good way of taking our sine wave, which if you remember has a range from -1 to +1, and then bringing it so it's just positive value, so it just remaps into that 0 to 1 range. And there totally is. There's this node here, this constant bias scale. We just plug our sine wave into it, plug it into our number, you'll see it does exactly that. Inside the constant bias scale we've got two values here, a bias and a scale. All it really is an add and a multiply, but just packaged together into one node. So we take our sine wave, remember our range here, -1 to 1. If we add 1 to it, well, now our range is from 0 to 2. Well, if we half that, our range is from 0 to 1, which is what we wanted, isn't it? So, constant bias scale, literally just an add and a multiply, but the defaults have been set up in such a way that it remaps from -1 to 1 into 0 to 1. And you can see here the bias, same as this add, and the scale, 0.5, same as the multiply. And to do it in reverse, you just do it in reverse. So to take this, first thing we would do with our 0 to 1 range would be to multiply by 2. That's going to take it back to the 0 to 2 range. And then we can subtract 1. And that'll take it back to our -1 to 1 range. So yeah, constant bias scale, or an add and a multiply together. I don't think there's any difference in cost, because they're basically doing the same thing. But I'm not 100% sure. But there's also this node, this function. Comes with the engine, remap value range. Basically does exactly the same thing. So you need to tell it what the input ranges are and what the output range you want is. So in our case, our sine wave, we're going from -1 to 1, and we want a range from 0 to 50, and it just does all that maths for you, which is great. The other question also asked how we could use that when we combine multiple sine waves together with different periods, which is a technique I showed in the last video, I think. But again, always thinking value ranges. So each of these sines, -1 to 1. That's the max and min value I can get from this sine wave. We know this, you can double check it. So if I add two sine waves together, the max and min values are just added together. Sometimes these sine waves are going to go inside, in which case we'll get -2 or 2. Like I say, we can double check this. Because these are different periods, it happens quite infrequently, but it does happen. And the same if we do another one here, -3, 3, because we've just combined them all together. So now we know what our input and output range is. We could either use the remap and just put -3 and 3 here, or we could do a little bit of math. So if I know my range is -3 to 3, if I add 3, that's going to get rid of the negative numbers, isn't it? That's going to make sure everything's positive. My range now here is from 0 to 6. And how do we get to 6? How do we get from 6 to 1? Well, we multiply by 1/6, don't we? Little trick we can do in here. I don't know what 1/6 is off the top of my head, but I can do 1 divided by 6. And Real's built in a calculator to every math node in here. And so now, if I've done this correct, we're back and we're always sticking within that 0 to 1 range. So, there we are, 0 to 1. So yeah, so there is ways we can do this. I would always work by combining stuff first and then bringing it back. But you could obviously just do each sine wave in 0, 1 first and then combine those in other ways, or however you want to do it. But and obviously it makes sense to pay attention to kind of where your numbers are, what kind of value ranges you're doing. But when you're doing this kind of stuff, usually you're multiplying by a parameter anyway afterwards. So no matter what my range is here, I can always have some scalar parameter later on that's going to let me get back to where I need. All the time when we're using maths, it's just a tool to an end, and the end is a visual result. So as long as it looks right, it probably is. We're not looking for the perfect number, we're looking for the perfect visuals. So yeah, that's the constant bias scale node. You can use that to remap some things, or remap value ranges, all this good stuff. So, moving on. Today we're going to be talking about some UVs, but before that I just want to introduce these two new nodes, masks and appends. So I have here is a colour. You can see it's this nice kind of like turquoisey blue, green kind of colour. It's also a vector, XYZ. So RGB, XYZ and UVW are kind of interchangeable. And I can just use this node here, this mask. I can take out the red channel. So I can just isolate the red data. Now it's black because black is 0. Now it'll be white. White is 1. 0.5 for mid-grey. All that good stuff. So quite often, less often with colours, but more often with UVs, you kind of want to just separate the two out and only work with one or the other. And you'll see that in a minute when we get to the UV examples. But the way we do that is by masking. And we can do a mask by red-green. So the default even settings are to mask by red-green. And that will give us this green colour, won't it? Because it's going to be 0 in red and then 0.5 in green. And it's just assuming nothing for blue when we plug it into colour. So if you've been doing blueprints or you come from a more programming background, you might have heard of this term breaking. And it's just doing exactly that. So we take our vector 3. Well, Unreal calls them float 3s, I would call it vector 3. But it's the same thing. It's a 3-component value or item of data. So break out float 3. It gives us this node, and that just isolates those 3 values out into red, green, and blue. And if we open this up as a function, it's just masks. That's all it's doing, just for convenience. Not get ahead of ourselves. Where are we? Here we are. So if we're using masks to break things out into separate channels, how do we bring them back together? We append them. And you can see here, hopefully, I broke out the red and green channels, and then I appended them back together. I'm not adding those values, I'm increasing the amount of data within them, if that makes sense. So if I just take this append chain, start again. If I just plug in 3 values, this is going to be my red, green and blue. So if I say, well, 1 in red, and appending, if I say 0.5 in green, and you can see we're building up those colours. So it's individual channels of data. And in the same way you can plug 2 appends together, there's also this node, make float 3. And guess what's inside it? It's 2 appends. So it depends really what method you'd like to use. If you're a bit old school like me, you might want to use masks and appends. If you've been doing more blueprint stuff, it's probably easier to use make, breaks and makes, but they are literally the exact same functionality. This is just combined into one node. Some of these functions you don't get the little preview icons and stuff like this, but it's probably fine. So now we know how to mask and append these things. Let's start talking about some of my favourite things, which is UVs. So you've probably already used UVs. If you plug your texture coordinate into a texture, some sort of brick. Quite like brick as my examples. So this text coordinate. So what exactly is this doing? So if we don't have one plugged in, it just assumes the default. So it assumes one of these has been plugged in. And you can see here in the tooltip it does say that defaults to constant coordinate if not specified. Well, that's what this is. So so what actually is our UVs? Well, if we look at it, whoops, not delete it. If we look at it, let's delete this one. It's got this kind of red and green colours, and hasn't it? It's not loaded. There we go. So I can break this into 2 channels. I know there's no blue component. It's going to be 0 in blue because it's only dealing with UVs, and it's actually a gradient. Black on one side, white on the other, and that's in the red channel. So that's giving our pixels across. And then another one, another gradient down, black to white, here in our green channel. So what does that mean? Well, if you think of this as a grid of squares, which is basically what it is, it's all pixels, isn't it? Every single one of those squares has a unique pair of numbers. So 0, 0 up here, 1, 1 down here, but somewhere like this is going to be, let's do it in the actual gradient, in actual UV, somewhere like this is going to be, I don't know, 0.6 red, and then 0.4 green. So it just gives us a unique way of mapping this data onto our texture coordinate. So onto our texture, yeah. Don't know if that doesn't make sense. It's a little bit complex maybe, but the important thing to take away from this is it's two gradients, one in red and one in green. And what's nice about these gradients is we can use them in our shader for all sorts of things, because they're mathematical. They're not I don't know. They're derived purely from maths. They start at 0, they go to 1. So if I look at this next example, this looks very similar. It's a UV square, but this isn't something that's coming from the engine. This is something I've made in Photoshop and imported. And you can see maybe some compression errors and this kind of stuff. And if I plug that in here, just using the red and green values, you can see how distorted this is. Really bad, isn't it? So if you were importing a gradient from Photoshop, you wanted to paint a gradient mask on something, if you brought that in from an external program, it's going to get compressed. You could turn off compression, etc. But actually, if we're using a gradient, why not just use the ones we already have? These are basically free. They're already in the engine. So yeah, they're mathematical. They start at 0, go to 1, but we can change that. We can do some things with tiling. So where am I? Down here. So if we have a look here, I've set the U and V tiling in my my text chord node up to 4. So I'm getting 4 times of my nice debug UV texture, which is cool. But if we look at the preview window here, you can see how the values hit that yellow and then stop. Well, what's happening? Plug this one in. Values here. They're all going up greater than 1, and Unreal can't display that. Can't display it here in the preview window. If I plug it into emissive, we might get some sort of glowing down here. So it's showing us there is values over 1. But we can also use a math node to get this back. We can use the frac. Covered it last time. What does it do? Well, it just replaces or just ignores the whole number part, doesn't it? So visually, this is the exact same result. Oops, let's just use one of those. Here's my 4 tiling 4x4, but actually what this is doing is tiling over the same first 0 to 1 repeatedly. If I just jump into Maya and take a quick plane, open up the UV window. So effectively, here we're looking at our UVs. By tiling it 4x4, we're taking 4 lots of squares and repeating it, and because the way UVs work, it tiles. So we're getting that 4. So that whatever pixels are in here, they get repeated again and again as we get our 4x4. Maybe I'll just do it. So that's our first example where we're using that 4x4. But by doing the frac, effectively what we're doing is taking each quarter and repeating it again and again over that first 0 to 1. So if I make 4 of these, that's 5. Each one of these is now repeating over that first bit again and again. Cool. So it's only the decimal point part of the UVs that's actually doing anything. 1.1 is the same as 2.1, is the same as 0.1, etc. Which can be useful. So, quick aside. Just want to talk about sRGB for a second. So this is not the way to do this, but hopefully it demonstrates the principle. When you import your textures into Unreal, we have this option here to use sRGB or not, and it tells you there it should be unchecked if using alpha channels as a mask. So if you're using substance, that kind of thing, you're channel packing your roughness and metallic or things together, you want to make sure that this is going to be unchecked. It's going to give me this error. Check it back on again. So what is it doing? Well, it applies a correction curve. Let's correct now. Okay, and you can see if I compare this to the one that has been sRGB off, this one's been turned off, it's been disabled. So that's trying to undo the correction curve. It's not perfect. These two lines are a bit closer together than these ones. So that's probably more Photoshop's error than Unreal's. But you can see how here the gradient is a little bit better, a little bit more accurate compared to the sort of the pure math one. If we've got the sRGB turned on, we get this horrible kind of like extra smearing over here. So what's happening? Well, basically when computer graphics was first started, people decided that what looked mid-grey and what was actually 0.5 grey weren't the same. So they added this artificial curve of gamma, they call it. So it's root 2.2, I think, something like that. But basically, it screws everything up. So it's not great. So when we're using colour, we need to know that that's fine. We want the gamma curve on because that's what we've authored it with Photoshop. When we're using our masks purely as numbers, so in this case, I'm using it to control my red channel. Then we need to turn sRGB off. So when you're using individual channels, fine, sRGB off. If you're using all the channels together, red, green and blue, sRGB should be on. Cool, so now we know a bit what UVs are, know how they work, we can do some fun stuff with them. So if I take my UVs and I just add time to them, remember these are just numbers, it's just data, we can do what we like. If we add time, we get movement. What's happening? We've just taken our UVs and we're adding to them, and they're moving up diagonally because we're adding equal amounts in red and equal amounts in green. We get that kind of appearance of movement, appearance of scrolling on our texture, which is pretty cool. We can do a lot of powerful things with moving textures. So here I'm adding time to both red and green at the same time. That's great, but maybe that's not what we want, this kind of diagonal movement. But we know from earlier that we can split up and recombine our channels. So if we go back to our panner, I've just masked out the red channel, and I'm adding time to that and appending it back together. So here we split it up into two, here we join them back together, and now when we're adding our values in red, we get horizontal movement, which is pretty cool. Lots of cool things we could do with that. Conveyor belts and neon signs and all those kinds of things. But we can also use this. So in these examples here, I was adding time. So I was adding a value that was always constantly changing, always going up. If we just add a value, just a number, we can move things around. If I add 0, nothing happens. If I add 0.5, it's going to change where this 1 square was. It was over here in the top left. Yep. If I add 0.5, it's going to move it half a UV across. If I add a quarter, move it a quarter. Oops, other way, quarter this way. So we can use just some numbers to tweak our arrangement, our offset. And there's a node that Unreal already has, which does exactly that. It's the panner node. So if I just create another one from scratch, one thing to note when using the panners is the defaults. There's no speed in X and Y, so it's not doing anything. If we want to see any movement, put a speed of X in. Now we're getting that horizontal movement. Excuse me. And we can control this. So this now is then panning across. This is the same as our adding time. We could plug a number into time. There we are. We've recreated the same thing here where we're just adding 0.5 is going to push it to the middle. If you do want to use your panner to do offsets like this, it's a good idea to keep the speed value to 1. If we put 0.5 here and 0.5 here, well, those two are now being multiplied and we're only getting an offset of a quarter. I'll change this one. Let's change that offset X. G5. So you can see here the offset of a quarter there, because our panner speed was set to half. So it's a good idea to keep that to 1 and just let this number do all the work. And now I can do my offset quarter. Be the same. So cool. Right, yeah, let's crack on. It's getting quite a long video, but that's fine. There's some cool things to get to. So this is moving. This is using some numbers that we're adding to our UVs and getting things to move around, but we can also do rotation. I'm not going to rederive these from scratch because rotation algorithms are a little bit more complex, but just know there is a node inside Unreal. Plug our UVs in, so coordinates. So UV coordinates, whenever you see this word coordinate, it's commonly it's going to be referring to the UVs, and here we've got text chords. Then we can do a time. So the defaults, well, let's have a look at this. We've got our center of rotation, so you can see it's rotating around the middle. That's cool, that's probably what we want. We can set this to 0, 0. Now we're going to be rotating around this point. So this is just the where on the UV coordinate we want to rotate around. I set to 0, 1, that's going to be down here. So we can change our centre of rotation, but 0.5 is usually pretty good. For some reason the default speed is 0.25. I don't know why. Probably, again, want to set that up to 1. Just makes all the maths a bit easier when this is set into 1. As I said before, it's about the visuals. If it looks right, it probably is. Don't worry about it too much. But since we're doing maths this time, I want to keep this as a number that makes sense. So, yeah, that's a rotator. That's rotating things around. We might want to control the speed of our rotation. What we can do, we can change this value in here, make it lower, make it higher, all that stuff. But this isn't a value that's, or a parameter that's exposed to the engine in any way. Well, we can make our own. So here, this thing says time, and it says it in the tooltip. Defaults to game time if not specified. Well, we have time. It's a node outside. We can just create it, plugging that in. These are now doing the exact same thing, and you can see that the pictures, they match up. But if we multiply time by a value, we can make things faster or slower. Time, again, it's just a number, all just numbers at the end of the day, so we can combine them however we like. So if you put it right down, 0.25, and this is now a value that we can expose to gameplay, or we can tweak in different ways, which is a much better way of editing than trying to go in and hard code these values in. So what happens if we wanted to rotate by half? So similar to the panel example earlier, if I put a constant value in here, it doesn't give me the right result, does it? Half a rotation, that's not half a rotation. So the input value here is actually in radians. Quick break to Google Images. What's a radian? Well, if a circle has a radius, then the angle when the arc has moved 1 radius worth of length, so you can see this horizontal distance here and this curved distance here are the same, that angle is what's defined as 1 radian. And if we remember our maths, the total number of radians in a circle is 2 pi, and that's where this constant not magic number, but this constant number pi comes in. And don't worry if you can't remember pi, Unreal's got it for us. It's just a function. Type in pi, doesn't default to it for some reason. There it is, math pi. And if we just open up, it's a function. What's in it? Just a number, 3.141592, etc. Don't need to worry about learning pi. That seems like a complete waste of our time. We'll just use the node that it's got. So if I change, look at this example here. We have our UV coordinates plugged into our rotator, and the important thing here again is that speed of 1, because this is going to be part of our multiplication. But now 2 pi multiplied by value that makes sense to us. 0.5 is now half a rotation. 0.25 is now a quarter. 0.125, that's going to be 45 degrees, and you can see those angles there. So if you do want to use your in-engine or your shader to do rotation, it needs to be exact. You need to remember that your rotator needs to be in, or the input there, the time input needs to be in radians. Hope that makes sense. One last thing about rotating. If we are rotating by 90 degrees, we could also do what's called swizzling. Just swapping the coordinates. So here, if I plug my xy in and get yx out, base color. Here I've got my texture normally laid out. If I swap the input coordinates, so u is now v and v is now u. Okay, this one goes backwards as well, but it's rotated 90 degrees, and all it's doing is breaking those two components out and then making them back together in the opposite order. You can see it's doing that, masking and appending in the opposite order. So this, if you're only doing a 90-degree rotate, is much cheaper, but if you want to have access to all the other angles, 45 degrees, etc., then you can do it by making sure you have your input into your rotator time in radians. Cool. Moving swiftly on, there's a couple more things to get through. Before, we were looking at tiling. So if I take my UV coordinates and then multiply by a value, I can control the tiling. So this is now 2 by 2. But if I do a value less than 1, let's say 0.5, it's zooming in that top corner, isn't it? So we're not actually zooming into the center of our texture, because it's scaling around the 0, 0 point, which is this point up in the top left. Maybe that's fine, depends what we're doing, but it's quite easy if we wanted to do like a kind of a zooming effect on our texture. We just need to recenter where that 0 is. So if I just run down this line slowly, this one is just our UVs plugged in, we get the whole square. Nice. If we subtract 0.5, 0.5 first, it's just moving what was the 0, 0 point into the middle. So you can see this intersection between the 1 square and the 64 square is now in the center. Now we can multiply by a half, and it's going to zoom in to that point, and then we add our 0.5 back, and that's going to offset, and now we can see actually we've zoomed into the center sort of 4 squares of that original texture. 4 by 4 squares. If we scale to 0.25, now we're going to get those 4 middle squares. So, as always, just numbers, just maths. If you put the right numbers in, you can make it do the right things. This is a very specific texture. It might be that if this was just clouds noise or something like that, you wouldn't need to necessarily zoom in on the middle, but you can do some cool things with this, and then you can create some offsets with some adds and various things. And the final thing I want to talk about with UVs is UV distortion. I just jump back to the first example. Because they're just numbers, there's nothing stopping us using textures and combining them together. So I've broken out the two things, so I'm just adding purely to my green channel, and I've got this texture, this sphere mask, and I'm adding a little bit up, and you can see you're getting this bulge in our green channel where I've added that in. And notice I'm adding a very small amount. If I add a whole 1, if I add all of this texture, it gets really distorted. So when we're adding values to our UVs, we can be really quite subtle, and we'll get quite a lot of a result. And if we animate this texture that I'm adding, we can create some really cool kind of slightly wavy results. Very powerful technique, very powerful indeed. Lots of things we can do with that. Like for example, noise. If I just add some noise to this, it kind of looks like it's underwater. Kind of looks like there's some waviness. There is one thing to notice. If I just bump up the intensity slightly, notice it's no longer centered. Because we're adding values, we're pushing it up. We're pushing up both the values in x and y. So our value range here was from 0 to 1. Well, I've added 0.1. So my value range here is now from 0.1 to 1.1. Maybe that doesn't matter. If what we were doing was just some random noise, the fact that it's been offset isn't going to matter at all. If this was sort of the base of a swimming pool though, and you wanted to keep the thing centered, well, we can do that. It's nice and simple. A bit like the scaling example, we just need to recenter where we are first. So, adding the same texture, and thinking about our value ranges. So here, values here go from 0 to 1. Values in this grayscale texture also go from 0 to 1. But if we subtract 0.5 first, our values here now go from minus 0.5 to positive 0.5. So effectively, for every pixel that we're pushing left, we're also pushing another one right. For every one we're pushing up, we're pushing another one down. And we're keeping them centered. And we're still multiplying by an intensity, so that's actually going to be minus 0.05 to 0.05. Because we're adding it, we're keeping the center of the range the same. We're keeping that 0.1 the same, that 0.5 the same. Minus 0.05 to 1.05. You see that? So we're getting a little bit of this wrapping. That's where we're going values over 1 and 0. But the average value of our range here, which is the middle, 12.5, is also the same after we've added our UVs to it. So it's keeping that center point, or keeping the sort of the texture centered on the plane. Cool. Right. Well, that was quite a lot of stuff today. Hopefully that all made sense. Yeah, these have been really popular, so I'm going to carry on doing a few more. We've got some fun things to get to. But as always, if you have any questions or comments or anything like that, please do let me know, and I'll see you all next time.